Hello, am I audible? If I'm audible, please write down in the chat yes or no. Okay, so let's start the post analysis. Okay, so the first question, first of all, we'll cover up the MCQs and then we'll move towards the coding question. Okay, so the first question says that you have to find the shortest distances between every pair of vertices in the given edge weighted directed graph, right? Okay, so you'll get the results afterwards, I guess. Okay. Just a minute, guys. Okay, so let me introduce myself first and then we'll move towards the uh, analysis of this contest, right? So my name is Jay Dalsaniya and I work as a course mentor at Geeks for Geeks, and that's my short kind of introduction. Okay, so let's begin. Already it's like 20 minutes, right? Okay. So in the first question, you can see you have to find out the shortest distances between every pair of vertices in the given edge weighted directed graph. So this is a pretty basic question. So in this, and the prerequisite is that you need to know Floyd virtual algorithm. Hello, just a minute. Hello. Hello. अरे सिस्टम हैंग हो गया तो मैं वापस रीस्टार्ट करूंगा तो नहीं होगी। अरे ये चिपक गया है मेरा लैपटॉप।
Hi.
Oi, so they give access to their job portal, Geeks for Geeks, for free?
Yes, complimentary with the course.
And you got your job through that?
Me and 15,000 others across the world.
No way!
Oh, yes, Wiz. Don't delay. Enroll now.
Geeks learning together.
Yes.
Hey, what do you mean by a self-paced course?
Well, the course material is available in the form of video lectures. And there are multiple practice problems that come along as well. So, you can access all of it anywhere, anytime. And they are available to you for lifetime.
No way!
Oh, yes, way. Don't delay and enroll now.
Geeks learning together.
Hi.
Oi, so they give access to their job portal, Geeks for Geeks, for free?
Yes, complimentary with the course.
And you got your job through that?
Me and 15,000 others.
Sorry guys, I was having some technical issue from my end. Okay, so now we'll go through this session smoothly. Okay, is my screen visible, everyone? Okay, so now let's start. So, in the first question, you have to find the shortest distance between every pair of vertices, and you are given edge-weighted directed graph. So, the graph is represented using adjacency matrix. So, here the prerequisite is that you need to know Floyd virtual algorithm. So, Floyd virtual algorithm is an algorithm through which you can find the shortest path between every pairs of vertices in a directed graph. So pretty basic. So you can directly apply the Floyd virtual algorithm. So if I apply the entire algorithm on this input matrix, it will take too much of time. Okay. Okay. So, and moving on towards the next question, I'll quickly cover the FT questions and then we'll focus on the coding questions because we are running short of time and we already have lost half an hour. Okay. So the next question says the 18 faces of each dice are numbered from 1 to 18 for given 6 dices. Okay, we need to find how many ways we can get the value of the sum as sum as 11. So that means you have 6 different dices, right? And all of them, it is not mentioned that on dice number 1 which numbers will be written, on dice number 2 which numbers will be written, right? So this is in this you can try out all the combinations, but it will be very much difficult for you to try out all the combination. So what you can do, you can create a 2D matrix, and while creating a 2D matrix, you will have two options, like whether you can cover up this dice or you cannot. You can in short, you will be having, let's say 1, 2, 3, 4, 5, and 6, right? And on each dice you will be having 1 to 18, or you can say that it will be distributed equally, or the distribution is not mentioned. So you can create the 2D matrix and fill out the 2D matrix with the help of DP, right? We have the DP formula. So filling up this matrix will not be over here. The row numbers can be taken as the sum, and over here you can take the integers 1 to 18, right? So you can find out then how many ways you can uh, formulate the, and how many ways you can find out the sum to be 11. And in this question, question number 3, you are given a matrix of dimension 5 cross 6, right? And each field represents a ton of gold, right? Each integer represents the ton of gold at that mine. Initially the miner is at the first column, so this is the first column, and he can only move in the rightwards direction, in the right upward direction, and right downward direction from the given cell. If this is the cell, he can move in this direction only. So it is the question says that he is at the first column, so you have to find out that what is the maximum number of gold he can collect if there are only 3 possible ways in which he can move. So if I start from this is the first column, and if I walk greedily, then if I pick up this 8, then this will move from this 8. You can move in 6 or 0th direction, right? You will move in 6th direction, and then further moving on in 6th direction. From 6 you can move in downwards direction, and from 5 you can move in 4, and from 4 you can move 9 in this direction. So you will be collecting 8, 6, 6, 5, 4, and 9, and that will add up to 38, and that is your answer. And in this next question, you have to find out the Huffman code for H, G, H, I, and J. So for this you need to create the entire Huffman tree. If you create the entire Huffman tree, then the Huffman code for F comes out to be 1000. The Huffman code for G comes out to be 101. If I create the entire tree, it will take too much of time. You need to know that in the Huffman coding, whatever is the, let's say I'll draw the initial Huffman code. Okay, so how the Huffman code works. So here the list of the integers and their number and their frequencies are given, right? So the initial step is to pick up the minimum frequency integer. So over here, if I find out the minimum frequency integer, that will be d is equal to 3. Okay, you need to pick two minimum frequency integers. So one I got d is equal to 3 and the another one is 17, right? A is equal to 17. So here you can see d is equal to 3 has 3 frequency, and here you have a is having 17. So whatever is the number which is having a lesser frequency will be on the left side, and adding up their frequency 3 plus 17 will be 20. So I have removed this D and A. So you will remove from this list and you will add up this 20, this entire tree inside this. And again, you will pick up two minimum and so on. And after you have created the Huffman code, assuming that this is the final Huffman code, you will take the left hand side as 0 and the right hand side as 1. Okay, so the left subtree, whenever you are moving in the leftwards direction, you will take as 0, and whenever you moving in the rightwards direction, you will take as 0, take as 1, right? So over here for this, suppose if this was my Huffman code, then for this the output, that means the Huffman code for D would be 0, and for this A it would have been 1, assuming that this is my Huffman binary tree. Okay, in that case it would have been this way. You need to know how to create a Huffman tree. Okay, so here in this question you will be given a directed you are given a directed graph, and you are given few of these statements. So there are four statements, right? So here it is mentioned that the edge CD is a backward edge when the DFS start from the edge number C. But this statement does not hold true. If you start the DFS from the edge number C, then this D won't be. It is not the truth that this node comes. This CD does not come out to be a backward edge. But if you take a look at this second statement, that edge DC is a cross edge in the above directed, over here it should be directed graph, okay, not undirected. So here you can see the edge DC is a cross edge, and this statement holds out to be true. So you have to create in the next question, question number 6, you have to find out the correct maxip representation of the given array. Okay, so this is the array. You know, the heap is a complete binary tree, and the maxip, the property of maxip is that if this is the root of the maxip, then this root will be having the maximum value among all the nodes inside this binary tree. Okay, so that is the property of the maxip. So you can easily create a maxip with the help of this array. And the option 3, if you create the entire maxip, this option C would hold to be true. So let's talk about the question number 7. So in question number 7, you are given an array. In array, the first you are given the first element to be 2 is to 9, the second element to be 6 is to 1, 6 is to 11, and the third element to be minus 3 is to 11. With the base value of 600 and the size of each element is 8 bytes in the memory, find the address of the element ARR of 5, 2, and 3 with the help of column measure and column measure order or and row measure order respectively. So over here, if you know about the column measure and order measure formula, you can find out that each and every element is having 8 bits of size. So you can put out this ratio and use the size of each and every element and the base value, and you will be easily able to find out the answer to be 2400, 2440 and 1800. Okay, so for that you need to know column measure and order, column measure order and row measure order. So let's move towards the question number 8. What is the inversion count for the given array? So if you don't know about the inversion count means if if for some element the index is I and for another element the index is j, and it is the case that the index I occurs between the index j and the value present at the ith index is greater than the value present at the jth index, then that means these two elements form an inversion. Okay, so you have to find out how many elements in this array satisfies this kind of condition. So that means first of all I'll take this one, okay, and I'll find out in this much of part how many elements are lesser than 1. So 1 is the smallest element and I cannot see any element lesser than 1. So now let's take another element. So another element is 30th. So if I take 30 and if I search in this much of part how many elements are lesser than 30, so I can see 6, 15, 2, 9, 14 and 22, right? I've covered all of them. So here you can see uh, 1, 2, 3, 4, 5 and 6 elements are lesser than 30 and they are occurring after 30, right? So you can include the 6 in your inversion count, and similarly for each and every element you can count this inversion, and then the final output, if you add up the inversion for each and every array element, the final answer comes out to be 28. So moving on towards the next question. So in the next question, the following are the elements 10, 9, 8, 7, 6, 5. Okay, are inserted into an empty binary search tree. Okay, so we know the property about the binary search tree. So in binary search tree, if this is my root and this is my left subtree and this is my right subtree, then all the elements in the left subtree are going to be lesser than this root, and all the elements in the right subtree are going to be greater than this root, right? So if I create a binary search tree with the help of these elements, the binary search tree will be like this: 10, 9, 8, 7, 6 and 5. So this is a skewed binary search tree. And what is the height of this binary search tree? It is equivalent to the number of elements. Okay, so in case of a skewed binary tree, the height comes out to be order of n. In this question, they are asking what will be the height of this binary search tree. The binary search tree is formed using this array elements. So the answer comes out to be n. And the next question, you have to count the number of set bits. So it is pretty easier to convert a decimal number to a binary number 1456. So you can keep on dividing it by 2. 2 sevens are 14, and this gives 2 twos are 4 and 2 eights are 16. So the remainder will be 0. You can find out the binary representation for n is equal to 1456, and you will observe that there are 5 bits set, and hence the output comes out to be 5 in this case. So over here, what are the minimum number of, so in the next question, question number 11, what are the minimum number of swaps required to convert binary tree into binary search tree? So this question is a derivation of a pretty standard question. Okay, so if you know how to uh, find out the minimum number of swaps required in order to convert an array from unsorted to a sorted manner, then this question becomes pretty easier. So for that you need to know the algorithm. So I'll explain it properly. So you know that in binary search tree, if you do the in order traversal of the binary search tree, let me draw a binary search tree. Let's say 8. This will be, let's say it is 6. Over here it is 7, and over here it is 5, and here 13 and 10. So this is a binary search tree. And if I do the in order traversal, in order means left subtree, then the root, and then the right subtree. So if I do the in order traversal will be 5, 6, 7, 8, 10 and 13. So here you can observe that the in order traversal will be sorted, right? So the in order traversal comes out to be in sorted manner. So what you can do, you can sort this array. So this is the input array, right? So you can sort this input array. So if you sort this input array, let's say we'll sort this input array. So the first smallest element comes out to be 7, and the next element is 11. The next element comes up to 20, then 28, 20, then 28. Let me rub this. 7 has been taken care of, 11, then 20, then 28, right? And then the next element, smallest one will be 45, right? And then the next element comes out to be 61. So first of all, you need to sort this array, right? 61, and then what is the smallest one? 89, 100, and 120. 89, 100, and 120. So this is the sorted manner of this array. Okay. So assuming that this is the in-order traversal of the array which you are of the binary search tree which you are going to form. So if you write down the original array above this array, so it will be 100, 45, 7, 20, 120, 55, then 28, 61, 11, and 89. Did I miss any of the number? 7, 11, 7, 11, then 20, then 28, then 45, then 61, then 89, then 100 and 1. Oh, I missed 55. So 55 will be over here. So 55 will be over here. Let me draw it again. So in short, like 55 comes out to be over here. So this is 55, this is 61, 89, 100, and 120, right? This is the format. So we were writing the input array about this sorted array, right? 61, 11, and 89. So now I have created a sorted array and this is my input array, right? So this is the sorted array. So here you can see this 55 is already sorted. It is at its correct position, right? So I need to swap this all the elements. Instead, I need to somehow put these all the elements at their right position. So if you observe carefully, let's say in this input array, we should work on this input array. So we need to sort this input array. So in the input array, you can see 55 is already at its correct position. So there is an algorithm like minimum number of swaps required to make an unsorted array sorted. So over there, what is the algorithm? You need to find out the cycles. Okay, so you have to compare the sorted array and the input array. So if you compare both of them, then here you can see the 7 should be you have to compare the position of the element in the input array and the sorted array. So 7 is at this third position, but it should be at this position. Okay, and this 100 should be at the last position. So 100 should be at this position. So over here, instead of 100, 11 is present. So 11, where should be the 11 placed? 11 should be present at the second position. So 11 should be placed over here. So over here, 45 is present. So original position of 45 is over here. So 45 should be present over here. And 120, what is the position? 120 original position. It should be at the end. So 120 should be present over here. And 89 is present. So 89, what is the original position? 89 should be present at this position. And over here 61 is present. What should be the position of 61? It should be here. and over here 28 is present. What should be the position, original correct position of 28? So yeah, I can see in the sorted manner it should be at 20th position, right? And where should be this 20 present? I can see that 20 should be present over here, and I started from this 7 and my cycle ended at 7 only. So why was this cycle, why was I finding out cycle? So let me explain you. Like, let's say there was some array 1 3, uh, let me write down 1 and 1 3 and 5. So this array is clearly not in ascending order, not in increasing order, right? So how many elements do I need to swap in? Minimum number, I need to swap only this 1 and 5. And what is the original, what should be the sorted manner? 1 3 and 5, right? So here I saw that this one should be present at this first position, and this 5 over here should be present at this last position. So here you can see there is a cycle containing two nodes, 5 and 1, right? There is a cycle containing only one containing two nodes. So how many number of swaps are required? If there are n number of nodes, then n minus number of n minus one number of swaps are required, minimum number of swaps, so to make this sorted. So over here, if you observe carefully, there are 1 2 3 4 5 6 7 8 9 10 10 elements, right? And this 55, excluding 55, there will be 9 elements. So there is a cycle of 9 elements, 9 nodes, okay? And how many swaps are required? 8 swaps are required. So over here in this question, the output should be 8. I think there is a typing mistake over here, okay? It should be 8. Oh, and then moving on towards the next question, you have to check if the expression is balanced or not. You can clearly check out the opening bracket and the closing bracket, opening bracket and the closing bracket, and so on. And the output is yes for this question. And moving on towards the next section, let me rub this. So in this series, there is some pattern, okay? So I observed two pattern, that 10, then 12, 12 to 16, 16 to 22, and 22 to 30. And from 30 to this. So what I observed, that 10 plus 2 will give me 11, 12, and 12 plus 4 will give me 16, 16 plus. So here you can see 16 plus, how many times should I add? 16 plus 6 will give you 22. So 22 plus 8. So here you can see there is an increment by 2 as well, right? 2, there was plus 2, then there is a plus 4, then is a plus 6, then there is a plus 8. So what can you expect after this? You can expect there is a plus 10. So over here at this empty position, there should be 40. And similarly for this, you can observe one pattern. 14 plus 6, you will get 20. And over here plus 8, and over here you can observe 6 plus 8, right? So over here it should be 10, right? 6, then 8, then 10. This series is also increasing by 2. So here at this position it should be 38. So this is option 1, and option 1 is correct. So in this question, the sum of the ages of brother and sister is 30 years, okay? uh, in the question number 2, let's say I will call the brother by B and sister by S. It is 30 years, okay? And after 6 years, the age of the sister will be 2 times that the age of the brother, okay? After 6 year, if this is my current year, okay? So after 6 year, what will be the age of brother? It will be B plus 6. And what will be the age of sister? It will be S plus 6, right? So what is the second statement? The age of the sister will be 2 times that of the brother. So you can say S plus 6 is equal to 2 into B plus 6, or you can say S plus 6. You can write down this manner also, 2 into B plus 6. If you solve out this equation, S plus 6 to B plus 12, that is S is equal to 2B plus 6, right? So taking the 6 this side, S is equal to 2b plus 6. If you have two equations, equation number 1 and equation number 2, and you have two unknown variables, right? And if you have two equations and if you have two variables, then you can easily find the values of these two variables. You can solve out this equation and you will get the answer as 8 and 12 years. So the next question. Question number 3. There are 10 operators A, B, C, D, E, F, G, H, I, J. Okay, in how many ways can the arrangement be made so that E always comes before F? See, we have to arrange the alphabets A to J, right? There are 10 alphabets. So there is some strictness in the arrangement that E should appear before F, and the next arrangement says that F should appear always before G and G should always appear before H. So you can see among these 10 alphabets, these 4 alphabets have fixed position, right? So you have to find out how many different arrangements can be made using this one. So here you do not know how many numbers will be there between E and F, how many numbers will be there between F and G, how many numbers between G and H, how many numbers after H, or how many numbers before E. We are not sure. So what we need to do, we have to take down all the possibilities. So you can directly use simple permutation and combinations. We can use simple permutation and combination. How the permutation and combination? How did I get the idea? Because there was the question about arrangement, and whenever we have the MCQ or question about the arrangement, and you are given specific candidates, then it is possible or it is for sure you will be there will be permutation or combination. So among these 10 alphabets, these 4 alphabets are fixed, right? And how many different alphabets are remaining? Only 6 different alphabets are remaining. You need to place these 6 different alphabets. Okay, so among these 10 different empty slots, 4 empty slots will be occupied by E, F, G, and H. How many empty slots are remaining? 6 empty slots will be remaining. And how many different characters are remaining? 6 different characters. So over this first position, 6 different alphabets can be placed over here: 5, over here 4, over 3, 2, and 1. So this is nothing but 6 factorial. And we are not sure about the position, right? So among this 10, I can pick any of the 4 position for this E, F, G, and H. So that is 10 combination 4. And how many different positions for this remaining 6? That will be 6 factorial. If you solve it, you will get the answer. Okay. So let's move towards the next question. So in the question number 4, the price of the table was 15,500. Okay. And the shopkeeper was offering, let's say the price of the table was 15,500. And the shopkeeper was offering it for a discount of, okay. So now I can see the time is 2028. So I'll quickly cover uh, I'll give you the basic idea about this MCQs. Okay. The shopkeeper was offering it for a discount of 35%. Okay, but on bargaining, agreed to order to offer successive discount and finally sold the table for rupees 800 and 860. Okay, so what is the second discount offered by the shopkeeper? So there is a formula, a direct formula which you can use for the second discount. You need to know that formula. Okay. So I'll quickly give you the idea about the question in which you can directly apply the formula and which are the conceptual questions. I will explain the concept over there. So in this question, what is the angle between the minute hand and the hour hand of a clock? So if you look at the analog clock, so let's say let me draw the analog clock: 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. Okay. So in the analog clock, the time shown is 4:30. Okay. So if you precisely observe the analog clock, no. So whenever the time is not exactly 4 o'clock or let's say 12 o'clock or something like that, there is some variable in the minutes, then this hour end is not precisely at 4, but it is slightly ahead or before 4. Okay, so if you observe the analog clock, you will observe that the hour end and minute end are not precisely at uh, the specified number, they are ahead or before. So what you can do, uh, you have to find out the degree, right? You have to find out what is the degree minimum angle formed. So if you observe that between the hour end and minute end, there are two angles formed. I'll call it as theta 2 and this as theta 1. These are the two angles formed, right? And here, you know that the entire cycle is of 360 degree, right? If you have theta 1, then if you have the answer for theta 1, then what you can do, you can calculate theta 2 by doing 360 minus theta 1, and that will give you theta 2. So I simply need one angle. So how will you find the angle? You are only given the time. So what you need to do, you need to convert the time into degrees. Okay, so you need to convert their movement into degrees. So you know that in 12 hours the hour end will move 360 degrees, right? In 12 hours it will move the entire analog clock. So 12 hours, I can write 12 hours as 12 into 12 into 60, that will be 360. Okay, so that will be 360 minutes. So in 360 minutes the hour hand will move 360 degree. So in 1 minute, what will be the displacement of this hour hand? So for that, what you can do, okay, 12 into, I made a mistake over here. What? Okay, 720, not 360. Yeah, a simple mistake. Yeah, so 720, right? So in that will be 720 minutes. So in 720 minutes, 360 degree, in 1 minute, how many degrees? Okay, so you can simply divide 360 by 720, and 720 is nothing but double of 360. So that will come out to be 1 by 2, that is 0.5 degree per minute. This is the movement of our hand. Our hand will move 0.5 degree per minute. And what about the minute hand? So we'll find out the displacement of hour hand and minute hand in terms of degree per minute. Okay, so minute hand, so we are already given the idea about this minute hand. Okay, so we know that in 60 minutes the minute hand will move 360 degree. So in 1 minute, what will be the displacement? So that is 360 divided by 60, right? So that is 6 degree per minute. So minute hand will move 6 degree per minute. Okay, so we have the displacement of hour and per minute, and we'll take the 12 as my standard position. Okay, so with respect to this 12, what is the angle formed by my hour hand, and then I'll find out what is the angle formed by my minute hand with respect to this 12. So if 12 was over here and this was my clock, and this is my hour hand, it is showing 4. So first of all, I'll find out this angle, and then with 30 I know that this angle, what is this angle, I'll find out that angle, and then I simply need to uh, find this theta 1, and I can simply what I can do, I can do the I can take the positive subtraction of that angle formed with 12. So I have the displacement, right? I'll use this displacement to find out the angle formed with 12 o'clock, of angle formed with this 12, the angle formed by hour end with this 12, and the angle formed by minute end with this 12. So here you are given 4 hours, right? So converting hours into minutes, 4 into 60 minutes, right? 1 hour is 60 minutes, so 4 into 60, that means 240 minutes. Plus I said that there will be displacement due to the minutes added, right? Here the time is not 004 o'clock, precise time is not given to us, right? So there will be some displacement for the hour end, so you need to add the minute over here, 460 into 30, and you have to find out the degree, right? So this many minutes, how many angle, you know that in 0.5 degree there is 1 minute, you have the minute, right? So 1 minute is 0.5 degree. So this many minutes, how many degrees? So you can simply do 4 into 60 plus 30 into 0.5, you will get the angle of our end, that is called our angle. and then you have to find out what is the minute angle, right? The minute in we have the ratio of degree per minute for the minute hand as well, and we are given 30 minutes, right? So we have to find out what is the angle formed. So we know that for 1 degree we have so for 1 minute we have 6 degree of displacement. For 30 minutes, how much of displacement will be done? So that is 30 into 60. So that is 180 degree of angle is formed by a minute hand, right? Okay, so have we have 180 degree, and we'll have some of the degree by our angle as well. Let me find out it as well. Okay, 6 fours are 240 plus 30 divided by 2, 0.5 is 1 by 2. That is 270 by 2. Can write down as 1 3, and let's say 135. So you have the angle formed by hour hand and minute hand. Then what you need to do, you need to find out this theta 1 over here, right? We saw this theta 1. So you can do 180 minus 135, and this will be 5, and this will be also 5. So you get 55. And over here it is mentioned that you need to find the smaller angle. So you'll get 15 as the answer. Did I miss anything? There might be a minor calculation mistake, but you can pretty easily calculate this answer as well. I'm just quickly covering all the question. Okay, so in this question, you will, if you write down Geeks for Geeks first in question number 6, and below this you write down this, you will see that there is an increment of 4, and there is an a decrement of 4, there is an increment of 4. So each and every alphabet has a number, right? If I say A is at 1, B will be at 2 position, 3, C I'm calling it as third position, and so and so on. So G will be at something A, B, C, D, E, F, G at the 5 or 6 position, right? 7 position. So if let me write down. So over here, K, you can see what is the position of K. K will be uh, occurring after 4 alphabets after G. After G, H, I, J, and K, right? So after 4 alphabets, K is occurring. So you will find out some kind of similarity, that is plus 4, minus 4, plus 4, minus 4, and so on. And similarly, you can calculate the code for this one as well, for this GFG school as well. Moving on to question number 7. Let me erase this. So in question number 7, you are given different statements. Okay, so the first statement, I'll note down each and every details about this statement first. Let me clear out this. So the statements are Alia, Bhavya, Charan, Divya, and Ali. So I'll represent their names by first alphabet: A, B, C, D, and E. Okay, they are sitting in a cafe. Okay, so they are wearing a bracelet of 5 different colors. So first one is, let me write down the name of the color: silver, gray, or silver, black, gray, silver, then black, then gray, magenta, then peach, right? And these are the names. I'll write down the names over here: A, B, C, and D, and E. Okay. And the next statement is there. They are drinking 5 different kinds of coffee: espresso, doppio, and so on. Let's not get into the names of the coffee. Let me note down them as well. Well, espresso, then doppio, then just a minute. Okay, so the other was cappuccino and latte, right? So first of all, in this kind of question, we need to write down all the details so you will not be confusing yourself. Okay, so the first statement is that person wearing a peach bracelet is drinking cappuccino. Okay, so who is first of all we need to know person wearing a peach bracelet. Okay, is drinking cappuccino, and Alia does not drink ristretto, and Charan is drinking person wearing a peach bracelet. So whoever is wearing peach bracelet, so in front of the peach color I will write down what was the name. So it was cappuccino. So I will write down cappuccino. That person is drinking cappuccino. So the next statement is Alia does not drink ristretto and Charan is drinking doppio. So I have not mentioned that which person is going to drink which kind of coffee, right? So I will note down that information over here. So Alia does not drink ristretto. She does not drink. Okay, and what does the next thing say? That Charan is drinking doppio. Okay, so Charan drinks doppio. So next statement is Bhavya is wearing a silver bracelet. So in front of silver, I'll write down Bhavya. So here you can see Bhavya is wearing a silver bracelet, and Alia is wearing a black bracelet. Alia. So over here, and I'll remove this name Alia and Bhavya because they are assigned the bracelet as well. And Ellie, moving on to the next statement, Ellie is drinking latte and is not wearing a grey bracelet. So here it is mentioned Ellie is drinking latte. So about which person is drinking which coffee, I will write down over here. She is drinking latte, right? And is not wearing a grey bracelet. Okay. So over here in front of the grey bracelet, she is not wearing this. E represents Ellie. So if Ellie is not wearing the grey bracelet, either Charan will be wearing or either Divya will be wearing. So over here, any of them will come, right? It is not mentioned what which person is wearing grey bracelet. So what is the question? Which of the following statement is true? So Bhavya is wearing a silver bracelet and is drinking espresso. So is Bhavya wearing a silver bracelet? Yes. And is she drinking espresso? So we do not have information whether Bhavya is drinking espresso or not. Okay, so we cannot say whether this statement, the last part, is true or false. So let's move towards the next question, next statement, and then we'll observe if it is true or false. So Charan is wearing a gray bracelet. Okay, so let me say Charan. Okay, so here I can see it is possible that Charan can wear gray bracelet. Okay, so what is the second thing? Is drinking doppio. Okay, so over here let's see. Yes, Charan is very drinking doppio. So this statement comes out to be true. Okay, so we did not take the risk about the first statement because there was no information about what Bhavya is drinking, right? So we cannot say whether that is true or false. So the second statement comes out to be true. Okay. So question number 8, a box contains 41 empty bottles numbered from 1 to 41. Bottle is drawn and another bottle is drawn without replacement. Okay, find the probability that both the bottles will show odd number. This is basic permutation, like combination, right? If there are 41 bottles, and if you remove one bottle, and again if you remove one bottle, then there will be 40 bottles, and if you again remove one bottle, then there will be 39 bottles, right? So at first you have the option to choose from 41, and in the next step you have the option to choose from the 40. So you can use permutation combination, basic question, basic maths. And over here also, if you draw Rohan is walking, let me put Rohan at a static position. If Rohan is standing over here, the question says Rohan walked 40 meters towards north. So I'm taking this direction. Okay, north. This will be south, west, and east. Okay. So I've taken this above direction as uh, north direction. Okay. So Rohan is walking 40 meters in north direction. Then he turned right. So right direction means east direction and walked 55 meters. Okay. and then he turns right again. So his face will be in this direction. So if he turns right again, then that means he will be moving, this will be his right direction. So he will be moving in the downwards direction. So he walks 65 meters. So he walks 65 meters. Then he turns left. So his face is this side. Okay, so his left will be this side. So he turns left and walks 30 meters. And finally, he turns left. So his face is over this direction. So his left will be this. And how much he walks? He walks 25 meters. Okay. So in which direction and how many meters is he from his starting position? This is the starting position and he's over this direction. So you need to find out. Obviously, you can see if this was his starting position, you know, according to this will be his east direction. So this west and west, B and D will be cut out, and then you can find out this distance. This is 55 and 30, and that will be, so this much is 55, right? This is a square. Now over here also this is 30. 55 plus 30, that is 85, right? And moving on towards the last MCQ. Okay, so here you can see there are 250 scientists. So let me call the scientist by S and physicist by P. So 250 scientists and physicists are attending a conference. If the ratio of scientists to physicists is equal to 11 is to 14, then how many physicists are attending the conference? So if I remove this ratio sign, I need to add a variable. 11 times x plus 14 times x will be equal to 250, right? So I can find this variable pretty easily. So that will be 11 x into 11 plus 14 is equal to 250. So x is equal to 250 divided by 25. So x comes out to be 10. So x is equal to 10. So I know that 11 times x is equal to 2 for a scientist, and P psychiatrist 14 times x. So I need to find out how many physicists are attending. So this is for physicist. So P is equal to 14 times x, right? 14 into 10, that will be 140. So option number C. Okay. So now let's move towards the coding question of this part. Let me share the screen. Okay. So this was the first question, right? Geek and balls. Okay, so Geek loves to play with balls. Okay, so he decided to go to market and buy few more balls for himself. Okay, seeing Geek's love for balls, the kind shopkeeper offers him twice the number of balls what Geek already have. He will only offer this if the number of balls Geek already have is not a multiple of 2. Okay, so let's say if n is the number of balls Geek is already having, and if that n is not odd, that means sorry, if that n is not even, right? If that is not multiple of 2, multiple of 2 means that this n is not a multiple of 2, that means n should be odd. So if the input number is odd, then the shopkeeper will offer 2 times n number of balls, 2 into n number of balls. Okay, given an integer n representing the number of balls Geek already have, find out how many balls will be offered to him. So it is pretty simple. So let me take the example. N is equal to 10. So whether 10 is odd or even, so I can see n is even. Like, right, 10 is even. 10 is easily divisible by 2. So n modulo 2 will give you 0. So the input number n is even, and hence the shopkeeper will not give him any extra balls. So if I take n is equal to 11, I can see n is equal to 11 is odd. So the shopkeeper will offer him 2 into, and that is 2 into 11, that is 22. So you have to check whether the input number is odd or not. So for that you can simply use the modulo operator. Okay, so let me write down the algorithm. I'll write down the algorithm, and the coding part can be done in any of the language. Okay, just a minute. You have to check if n modulo 2 is equal to even. So if n modulo 2 is even, then that means the shopkeeper will not offer him any kind of toys. So in that case, if you complete the function, or in this case you have to return the value, so you can directly return 0. Else that means the number, if n modulo 2 is not equal to 0, then that means the number is odd, and in that case the shopkeeper will return him 2 into n number of balls, right? So that is the logic for this question. Pretty simple two-line code. You can also use a ternary operator if you don't want to use if else condition. Just a minute, I will change the question as well. Okay, so moving on towards the next question. Geek's favorite elements. Okay, one fine day, Geek gave a challenge to one of his friends. Okay, so the challenge was to find the sum of divisors of Geek's favorite elements. So there will be some number of elements which are Geek's favorite elements. That elements are Geek's favorite elements. Okay, so Geek's favorite elements are the integers in the array. So now we'll know about what are the elements which are favorite to Geeks. Okay, so Geek's favorite elements are the integers in that array that have exactly four divisors. Okay, so let's say if there is a number n and its divisors are only 4, exactly 4 number of divisors are of n, then that number is favorite to Geek. Okay, so that is the definition of Geek's favorite element, and this set of integers represent all the favorite numbers of Geeks. Okay, so here you will be given an array of integer a and a size of the array n. So you will be given an array whose size will be n. You have to return the sum of divisors of Geek's favorite element. So from this input array, there can be few of the favorite elements of Geeks and unfavorite elements, right? So from this you have to filter them out and find out all the numbers which are favorite to Geeks. And which elements are favorite to Geeks? The elements which have only 4 divisors, only 4 divisors. Okay, and what you have to do for each and every favorite element of Geek, you need to find the sum of their divisors. Okay, so let me take the example 6, 10 and 4. Okay, 0, 1 and 2, these are the indexes, and n is equal to 3. Output is 30. So let me find out, let me check one by one, we'll check whether the number is favorite element of Geek or not. So let me find out 6. For 6, how many divisors are there? I can see 1, 2 is also 2 and also 2 can also divide, 3 can also divide, and 6 itself. So yes, I can see there are only 4 divisors of 6. So it is favorite element of Geek. Okay, and what is the sum of all the divisors? 6 plus 3, 9, plus 1, 10, plus 2 is equal to 12. So the sum is 12. I'll write down the sum using blue color. Okay, so let's check about 10. So how many divisors are there of 10? 1, 2, 5, right? 3 is not the divisor, 4 not, 6, 7, 8, 9 and 10. Right, over here also you can see 4 divisors are there. So 10 is also the favorite element of Geek. What is the sum? 10 plus 5, 15, 15 plus 3, 18. Okay, so let's check about the last element 4. So for 4, how many divisors are there? 1, 2 and 4. Only 3 divisors. So it is not the favorite element. So we'll not add the sum of all the divisors in that case. So there were 2 favorite elements. So 4 does not come out to be the favorite element. So 12 plus 18 is the sum of the divisors of Geek's favorite element. So 12 plus 18 will be equal to 30, and hence the output comes out to be 30. So over here we have two major tasks. So what is the first task? First task is to find out that current element, let's say ARR of I, is Geeks favorite element or not. Okay, so how can you do that? You can do that by finding the number of divisors. Okay, and the next task is, if I have a number which is Geeks favorite element, then what I need to do, I need to find the sum of divisor of the Geeks Geeks favorite element. Okay, so the everything revolves around finding the divisors, right? In order to count the number of divisors, you need to find out which divisors are there. In order to find the sum of the divisors of a number, you need to know which all the numbers are the divisors, right? So there is one algorithm, or what you can do. Let's first of all understand how you can find these number of divisors or all the divisors of a number n. So what you can do, you can run a loop from 1 to n and find out how many numbers can divide n. Okay, I'll run a loop. It is from I is equal to 1 to I is lesser than n. Okay, and then what I'll do, inside this for loop, let's say I'm using a for loop, and inside this for loop, what I'll do, if the number n is divisible by I, then that means I will include it as my divisor. So I will, let's say, divisor plus plus, there was some variable, let's say divisor named variable, and it was initially 0. This is a counter variable. Okay, this counter variable will increase its value whenever this if condition is satisfied. Okay, so this is one of the method to find the divisor. Okay, so this method takes order of n time, that is order of num time. Okay, and here we need to find the number of divisors or the sum for each and every element, right? So if I take this n, let me call this as number. Okay, I'm running a loop on number. Okay, so if I call this input number as num, then the array is of size n, and there were n number of elements, num1, num2, num3, and so on. For each and every array element, you are running a loop that number of times. Okay, whatever is the element's value, that many number of times you will be running a loop if you use this approach. So our time complexity in that case will be n into num. Okay, but over here in the question they are expecting n into square root of num. So this approach in which we are finding the divisors, that needs to be optimized. And if we observe carefully, there is one more optimal approach. So first of all, that we need to observe something. Let's say if I take 4, so what are the divisors? 1, 2, and 4. Let me write down 10. What are its divisors? 1, 2, 5, and 10. Okay, so instead of running a loop number of element number of times, instead of running a loop 10 number of times in order to find 1, 2, 5, and 10, what you can do, you can run a loop square root of number of times, square root of num number of times. Why num number of times? Let me take the square root of 4. So square root of 4 will be 2, right? So if I have this many elements, then I can easily calculate the element on the other side. If I call it as partition 1, then I can calculate the partition 2 as well, right? Because any number, let's say if I talk about the number n num, it will be a multiple of 2 other elements, right? A into b will give you num. So if you have this a, then what you can do, if you want to find out b, then what you can do, you can divide this num by a, right? So if you have the elements from partition 1, then you can find the elements from partition 2 by simply dividing that element by 2, element by that number. Let me give you a proper example. You'll be able to understand with this one, with 10. Over here, square root of 10. let's say square root of 10, what will be the square root of 10? It will be somewhat greater than 2. I can easily say it will be greater than 2 because square root of 9 is equal to 3, right? So 10 is greater than, obviously greater than 9, right? So it will be somewhat greater than 3 to be precise. So I'll run a loop square root of number of times, square root of 10 number of times. That will I'll run a loop on the partition 1 only. If I run a loop on the partition 1, I can see if I can see I can find 1. I can divide 10 by 1, right? So if I multiply this 1 by 10, I'll get the number 10. If I multiply this 2 by 5, I will get this input number 10. So if I have 2 and I want to find that what will be its partner on the partition 2 side, then what I need to do, I need to divide 10 by 2 and I'll get 5. Okay, so I'll run a loop square root of num number of times. Okay, instead of running a loop for I is equal to 0, not 0, right? I need to find the divisor. So run a loop from 1 till I is less than or equal to square root equal to y equal to, because you can see for 4, you can write 4 as 2 into 2, the same element comes, right? You need to run a loop from I is equal to 1 till square root of number of times. Okay, and then if the current element, let's say num, divides uh, if this number divides, if input element num is divisible by I, then the remainder will be 0. Then you need to find out, what you will do, you will do two tasks simultaneously. You will count the number of divisors for the number and you will count the sum as well. Okay, so now I can see that I is able to divide number. So in that case, what can be the case? Over here you can see that in case of 4, when you divide this 4 by 2, the other element from comes out to be same, right? So I cannot include the same element again and again in the sum, right? If I was calculating the sum of divisors for 4, it comes out to be 7 only, not 4 plus 2 or another 2, right? Only it comes out to be 7, not 9. So now what I need to do, I need to check whether the other partition is similar or not. So I'll check whether this num when divided by I gives you the same element or not. If it gives you the same element, then I need to include it only once. So I'll include my count variable by 1 only, and I'll include my sum variable by that divisor. Sum denotes the sum of divisors. Else what I need to do, else that means the element from partition 1 and partition 2 both are different. If they both are different, then that means I need to increase the count by 2, correct? And I need to include both of them inside my sum. So I is one of the divisor, and num by I is also another divisor. That will be num by I. So with the help of this algorithm, what you can do, the help of this algorithm here, end of the for loop. With the help of this algorithm, you can easily find out the count of divisors as well as the sum of divisors for the input number num. And what is the time complexity of this approach? In this approach, the time complexity is square root of num. Okay, and if I follow this approach for each and every array element, then what will be the overall time complexity? It will be n into square root of num. That will be the overall time complexity in that case. So I'll write down this entire thing in one function and I'll call this function. Let me give some space. Okay, so I will include this entire logic in one function and I'll call that function each and every time. Okay, so let me write down the name of the function. Let me call it as, and this function will return an integer value. Okay, okay, and I'll call this function as fun. And in this function, the argument will be num. Okay, so this is the function. It will return an integer value. See, I only need to have favorite geeks element, right? If the count is equal to 4, then that element is geek Geek's favorite element. If the count is 4, then that element is Geek's favorite element. Then and only then I'll return the sum of the divisors. In other case, I will simply return the sum to be 0. Okay. And now I'll call this function inside my basic pseudocode. So let's say our pseudocode, if you observe in our ID, in the Geeks4Geeks ID, you will observe that it returns. Let me increase the. Okay. If you observe in the ID, that function, whatever is the function, let me check the name of that function as well. So let me share the screen only. So you'll get a better understanding. So I've written the code, okay? So this is the code for Geek's favorite element. So in this, I've used an answer variable, okay? And I'm running a loop on all the input array elements. And I'm calling the function as divisors, okay? This divisors function has the same logic which we wrote earlier. Over here we wrote the same logic and I have written it inside my divisor function. Okay, if the total number of divisor equals to 4, then the sum will be returned. Otherwise it will return 0. Okay, so and I'm adding whatever is the value returned by divisor inside my answer variable, and then I'm returning the value of my answer variable, and that's it. That is the simplest logic, and the time complexity is order of n into square root of n. Square root of num. Why square root of num? Because this loop will run square root of element number of times, and this outer loop is running n number of times. So n into square root of num, and that's the logic for this question. So let's move towards the next question. Make the same parity, okay? So in this question, let me quickly explain this question. So in this question, what you have to do, I'll explain on the board as well, so you'll get a better idea. Will college students get something if they are in top 10? Okay, so the instruction about the goodies and all, it is mentioned inside the description of the contest. Okay, so in this question, what you have to do, you simply, if I observe this question, you will be given an array. Okay, in short, you will be given an array, and you have to find out that is it possible that you can convert this array into same parity of array. That means all the elements will be either odd or all the elements will be either even. Is it possible that this kind of conversion is possible or not? Based on that, you have to output true or false. So how will you convert it? So for conversion, you have something like 0. These are the array indexes 0, 1, 2, 3, and 4, right? So there is only two different operations. For even indexes, you can increase the element by 1 simultaneously. Okay, and you cannot independently increase the value of each and every array element. Okay, and for odd indexed element, the same thing, you can increase the, see, if you increase one element by 1, then if that element's index is odd, then all the elements present at odd index, their value will be increased by 1. If you increase the value by 1 of an element and its index comes out to be even, then all the elements whose who are at even index, then their value will increase by 1. Okay, so this is the conversion. If you can do this, then and only then you will answer true, else you will answer false. So let me take the example 1, 2 and 1. Okay, so in this question you have to convert the all the elements to either odd or either even. So if I convert this even indexed element and I increase them by 1, so the final array will be 2, 2, 2, right? So here all the elements are even and hence the output comes out to be true. The output comes out to be true in this case. So if you observe carefully, let me take one more example. What you simply need to do, see, here we are increasing the value by 1, right? So let's say, let me take one number 3. If you increase 3 by 1, you will convert that odd number to even, right? And if you take an even number, let's say 2, and increase its value by 1, you will convert it into false. So here the condition was that all the even indexes and all the odd indexes will be increasing together, right? So here it should be the case that if at all the even indexes, if the even indexes contains odd numbers, then all the odd indexes should also contain odd numbers. Okay, then and only then you can return true. If this is not the case, and if all the odd numbers or either of them contains even numbers, then this you will increase all the elements present at even index by odd. So what you have to check, that all the even indexes or odd indexes, if you are targeting them, then all the parity should be same. All the parity should be same. So over here, if I observe this test case again, here you can see even index 0, even index 2, the elements 1 and 1, they are odd, right? That means all the odd indexed elements are odd in parity, So, and all the even index elements are even in parity. So when is the answer false? So the answer is false when this kind of condition is there. So here you can see at all the even indexes, all the elements are not having the same parity. Okay, if all the elements are not having the same parity, then you cannot change the parity of them by simply increasing by 1, right? So hence you can simply check the parity at even indexes and then the odd indexes. If they are not same, if any of the element is coming out of the parity, then simply return false. So let me show you the algorithm. Let me show you the coding part. The questions are pretty basic and pretty simple if you observe the statements properly. So this is the logic. So I have written the code in Java, but you can write down in any of the language. Okay. So what I am doing over here, I have taken the length of the array. N is the length of the array. Okay. And if I have an array of single length, then that is pretty sure that the element will be of the same parity. All the elements are of the same parity, right? Or else what I'm doing, I'm just finding even or oddness. So I'm simply dividing all the elements present at even index by 2 and then all the elements present at odd index by 2, or you can do this in a single loop as well, right? We are simply dividing it by 2. Why dividing it by 2? Either the remainder will be 0 or the remainder will be 1. Okay, and now what I'm doing, I'm iterating all the elements present at in even indexes. Okay, so I've taken a previous variable, I'm checking the parity of the first element. If the first element is even, then all the elements should be even. Okay, so what I'm doing, if the parity is changing, then I'm directly returning false. Okay, and now if for even indexes the parity is same, then I'm checking for the odd indexes. Okay, so I'm taking the parity of the first element. So whether that first element is even or odd does not matter, but that parity should remain same throughout all the numbers present at odd indexes. I'm running a loop on all the odd indexes. I can see the elements are not changing. If they are not changing, then pretty good. If they are changing, their parity is changing, then directly return false. And if false is not written, then that means the answer exists, and then you can directly return true. Okay, so that's it. Pretty easy and pretty simple, straightforward questions. So make sure to like participate in the next upcoming Biwizard contest. Okay, so you'll get the details on the website of Geeks for Geeks. I hope you enjoyed the coding part and as well as the MCQ part of the this Biwizard contest. Okay, so keep on coding. You guys are having a better opportunity, and the awareness about the coding has spread a lot. So if you start early, then your mind will develop a lot, and it will help you throughout your like life. This is nothing but simple problem solving. This DSA and everything is nothing but mathematics. Okay, so in maths, what we used to do, we used to learn a formula, and then we used to apply that formula on different kind of problems with different values. Nothing fancy, right? We had a problem statement, and we had a set of formulas, right? And we used that formulas in those problems to solve that problem. Similarly, this is the same thing as maths. DSA, we have some algorithms, we have a problem statement, we implement this algorithm and check whether we are getting the answer or not, and that's it. So make sure to participate in the next contest as well. Okay, so we are ending the session here only. I hope you enjoyed this session. Okay, bye bye.